So chapter 6, section 7, last section of this chapter that we're going to talk about anyway. I think it's the last one anyway. So this chapter is going to deal with what we call geometric sequences and geometric series, and then finding formulas to different things to determine if it's geometric or not, if the sequence is geometric or not, finding common ratios, doing those different types of things with the geometric sequences. And like I said, this is the last section of chapter 6. So we're going to start out with just a general definition. We want to be able to represent and use geometric sequences and series today. So in that order for that, we have to have a general explanation of what is a geometric sequence. A geometric sequence, as it says, is a sequence with a constant ratio between two consecutive terms, or between consecutive terms, and that ratio is called the common ratio R. So if you look at the table below, there's a couple of things we need to realize from this table. The first column is the term number, the number of term in that sequence. So the first term in the sequence is 4. The second term in the sequence is 12. The third term in the sequence is 36. And so on and so forth. So if you were looking this kind of as strung out, it would say 4, 12, 36, 108, 324, kind of dot, 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 and so on and so forth. Now, this is a geometric sequence if it has a common ratio between the two. And if you'll notice, this one does have a common ratio. It has a common ratio of 3, so we do say that this is a geometric sequence. But a couple other things that I want you to keep in mind when we're doing this. One is that n value. That n value means the number of term that it is in that sequence. The term value is the value of that term in the sequence. So the first term is 4. Another way you could write this is you could write it a of 1 is equal to 4. That means the first term of the sequence is 4. A of 2 is 12. The second term in the sequence is 12. The third term in the sequence is 36, and so on and so forth. And that's how you're going to have to keep that in mind, because a lot of times you're going to see this a of 1 equals what, or a of 5 equals what. Find a of 10. That means you have to find the 10th term in the sequence. And we got to be able to find that, and we're going to come up with a formula here in just a little bit to kind of help us find that. But the first thing we want to be able to do is recognize if it's a geometric sequence. Okay, and this is a geometric sequence because it has that common ratio of 3. How do you get the common ratio? Like a of 2 divided by a of 1 is 3. A of 3 divided by a of 2 is 3. So you've got that common ratio that kind of happens. So this sequence that we have here is a geometric sequence, since for n equals 1, a of 1 is 4, which makes my r value 3, and r is that ratio. It had the ratio of 3, and a2 is equal to a1 times 3, and a3 is equal to a2 times 3. So then we can say in general terms, and this is important right here, that the nth term in the sequence is going to equal a of n minus 1. A of n minus 1 is the previous term to a of n. So if a of n was, if you were finding the a of third value, a of n minus 1 is a of 2. If I'm finding the 6th term, that's going to be a of n minus 1. Well, my n value is 6, so this is going to be the 5th term times 3. If I'm going to find the 10th term, that's going to be the 9th term times 3, and so on and so forth. Now, this is what's called a recursive formula. Okay, so we can give this a recursive definition. Essentially, recursive essentially means that in order to find the value, the next term in the sequence, you have to know the previous term. If you don't know the previous term, it's going to be awful hard for you to find it. And that's what a recursive formula does. Okay? It allows you to find the next term in the sequence only if you know the value of the one before it. If you don't know the one before it, you can't find the next one if it's recursive. So in this case, the recursive definition for the sequence, 4, that's our first term. That's what that means. 3 times a of n minus 1s means we're going to take 3, our ratio, times our previous term. So 4 is the first term, n is the number of terms, 3 is the common ratio, and then it says the preceding term, a of n multiplied by the common ratio, is the next term in the sequence. Okay, so that's what that generally means. Okay, and that's, again, this is a recursive formula. And again, in a recursive formula, you can only find the next one in the sequence if you know the previous one. You can't find all of them. Okay? An explicit formula or definition, or an explicit something in the explicit form, something that's in the explicit form allows you to find any term without knowing the previous term. And we like explicit ones, because when we've got an explicit formula, then you can find any term in there that you want to find. Right? It doesn't have to be kind of this recursive thing. So in here is kind of an explanation. If we're given the recursive definition, 5 is our first term, and we've got the formula, our ratio is 1/2 times n minus 1. We can find an explicit definition for that geometric sequence. And we can find that by, again, they kind of lead you through the steps that shows the pattern. So you can read through that yourselves. But in general terms, the general explicit definition for any geometric sequence, and this needs to be in your notes, starred, highlighted, and everything like that. The general explicit definition for any geometric sequence is a of n is equal to a of 1 times r to the n minus 1. Okay, so a of n, the term of the nth value, is equal to your first term times the ratio to the n minus 1, where n is, again, the term that you're looking for. And this is the explicit definition. Again, highlight that, star that, use that. That's going to allow us to do lots and lots and lots of different things as far as writing things down. Okay, so let's look at some examples of things you're going to look at using the explicit formula. And again, I'm going to write that explicit formula down. A of n is equal to a of 1 times our ratio to the n minus 1. So the first one says, determine if the sequence is geometric. If it is, find the common ratio and the explicit formula. Okay, so my first term is 50. My second term is 504. So if I go 504 and divide that by 50, I get 10.08. If I do the next one, 5044 divided by 504, that's 10.007. That's not the same. So since it's not the same, these are not geometric. And you're done. If it's not geometric, you can't write an explicit formula for it. You're done. Okay, the next one. Negative 424, negative 144, and 864. So I'm going to go 24 divided by negative 4. That's times negative 6. So I'm just going to go 24 times negative 6, see what I get. Hopefully I get 144. I do. So that's negative 6. So we know this is geometric. So this is geometric. Now we have to write the explicit formula. So our nth term in the sequence is going to equal our first term, which is -4, times our ratio. Our ratio in this case is -6 to the n minus 1. And that is our explicit formula for this one. And you're done. Okay. And this first part, that's what you're just going to have to do. Is it geometric? Write the explicit formula if it exists. And now that we know how to write kind of that explicit formula, and we can tell if something is geometric or not, now we're going to determine if the sequence is geometric. And then if it is, we're going to find the common ratio and the term named in the problem, and we're going to write the explicit formula just to kind of help us out. Probably won't do it in that order. We'll probably find the common ratio first, then write it, and then do it. Okay? So -1, just kind of looking at it quick, -1, how do we get to 2? Multiply by -2. 2 times -2 is -4. -4 times -2 is 8. So yes. Okay, so this is geometric. It has a common ratio of -2. So the formula, the nth term in the sequence, is going to be my ratio. It's going to be my first term, my first term, -1, times my ratio, -2 to the n minus 1. Again, remember the explicit formula, a of 1 times r to the n minus 1 is our formula. Now we have our formula, now I want to find the 11th term. So the 11th term in the sequence is going to be -1 times -2. Now my n value was replaced with an 11, so my n value in my formula has to be replaced with an 11. So that's equal to -1 times -2 to the 10th. Make sure you follow order of operations. Do -2 to the 10th first, and then take that times -1, and you get -1024 is your solution for that one. Okay. The next one. Determine if the sequence is geometric again. Find the root, and see if you can find the next one. So go ahead, give you a few seconds. Go ahead and do question number 4. All right, so there's your solution. 786,432. Wrote it wrong the first time. Now, common error alert. Make sure you put that -4 inside parentheses when you're taking it to a power. Okay, because you got to take that negative and that 4 to a power. Okay, common error is just taking -4 and just squaring the 4. You can't. You have to square the whole thing or take it to the 9th power, the whole thing. So be careful. when you are doing those, that you put that R value inside of parentheses. Okay? So there's the second type of problem that you're going to have to look at. Now, the next type of problem, we're going to kind of take that next step, is we're going to say, okay, this time we're given two terms in the sequence, and we're going to find the common ratio, the term named of the problem, and we're going to write the explicit formula. Okay, so now this time, we don't know what the ratio is, so we've got to find that ratio. Problem is, we don't know what A1 is either. So leads to a little bit of an issue with kind of our formula. And one thing I want you to pay attention to in this formula, and I want to talk about the formula again real quick. So our formula says A of n is equal to A of 1 times R to the n minus 1. Now the A of n, the n value, and that A of 1, those are kind of arbitrary numbers. It can be any term. That n value, that A of n, that n value can be any term, as long as whatever you have written here and whatever you have written there are the same, you're good to go. You can put an you can put an 11 there, and you can put an 11 there. You have to put an 11 on your ratio. The same thing goes for this 1 right here. This doesn't necessarily have to be the first term, but you have to know what term it is, because whatever this value is here, this value has to be here. It doesn't necessarily have to be a 1. It's helpful when it is, but it doesn't have to be. So if I wanted to write, say, I wanted to find the 10th term, and I was given the third term, I can do that as long as I go to R to the 10 minus 3. I can do that, and that's okay. There's nothing wrong with that as long as we know what term it is. And that's really going to help us when we go ahead and solve now the questions like we have right now. And again, this and this have to be the same in your formula. Okay? And this and this have to be the same in your formula. So when we look at this type of problem, it says given two terms in the geometric sequence, find the common ratio, the term named in the problem, and the explicit formula for it. Okay, so in this case, we're given the 5th term, we're given the 2nd term, we have to find the 10th term. Well, in order to find the 10th term, the first thing we need to know is we need to know the common ratio of this. So we have to figure this out. Now, some of you could probably do it in your heads, but we can use this formula to find the common ratio. We know what our 5th term is. So I'm going to replace the A of n with what I know my 5th term is. My 5th term is 32. Now, it's key how I said it. It's my 5th term. So A of 5 is 32. That's going to equal, the only other term I have is the 2nd term. So the value of my 2nd term is 4. So that's A to the 2nd is 4. My ratio, I have no idea what that ratio is. Now that top number now, what is by exponent? It's n minus 1, technically speaking. But we don't have the first term, and we don't have an n sitting in there. But 32 was my 5th term. So since 32 was my 5th term, I'm going to put a 5 there. -4 was my 2nd term. So -4 was my 2nd term. I'm going to put I'm going to put a 2 there. The 5 comes from the fact that this was my 5th term. The 2 comes from the fact that this was my 2nd term. That's where those come from. Now they're going to allow us to find my R value. So 32 is going to be -4 times R. 5 minus 2 is 3. Divide by -4. So -8 is equal to R cubed. take the cubed root of -8. That's going to be my r value. Well, the cubed root of -8 is -2. So now I have my r value. Okay, so my r value in this case is -2. So that's the first thing they asked us to find. They asked us to find the common ratio. Next thing they asked us to do is name the common term. The term that they asked us for, they asked us to find the 10th term. So we have to find the 10th term. Let's switch colors here. So our 10th term is going to equal, well, I have my 5th term, so I'm going to use my 5th term. I could use either term. I'm going to use 32 because I know what that is. My ratio is -2. Now I have to go n minus whatever the term is. So my 10, 32 was my 5th term. So that's going to be 32. That's going to be 10 minus 5. So we've got 32 times -2 to the 5th power. Make sure you put that -2 inside of parentheses. Take that to the 5th power. Take that times 32, and you get -1000. A to the 10th is equal to -1024. Okay, so there's our 10th one. The last thing it asks us to do is it asks us to find the explicit formula. Well, in the explicit formula, you need the first term. We don't have the first term, so we have to find the first term. And it's kind of our explicit formula. Now, could you do it backwards now just by dividing by your ratio? Sure. You could divide by -2, divide by -2, divide, and get to where it's supposed to be. But just because. So we want to find our first term. Our first term is going to equal a term that we have, 32 times our ratio to the 1. Now this time, because that 1 is my first one, 32 was my 5th term. So that's going to be 32 times -2 to the -4th. So -2 raised to the -4th. And then you're going to take that times 32. And you're going to find that that is equal to 2. So our first term in this case is 2. So therefore, our solution to this would be, or our formula, a of n is equal to our first term 2 times our ratio, -2 to the n minus 1. And there are your solutions to this problem. Okay. A lot involved, in solving these. You have to find that ratio. You have to find the different terms that are in there. If they're nice to you, they give you the first term. But a lot to do kind of with the inside of this problem. Okay. So let's take a look at the second example. So we've got our first term, we've got our 6th term, we have to find the 10th term. So the first thing we have to do is find the common ratio. So we've got 243 equals 1 times r to the n minus 1. Well, 243 is the 6th term, so that's got to be a 6. 1 is the first term. Nice. So we've got 243 equals r to the 5th. So the 5th root of 243 is going to be my r value. So 3 is equal to my r value. The 10th term, then, if we're going to find the 10th term, I might as well just do that now. So a to the 10th is going to be a of 1. We can write our formula now too, I guess. 1 times our ratio, 3, to the 10 minus 1. So that's going to be 3 to the 9th. Oops, so 3 raised to the 9th. is 19,683. That's our 10th term. The nice thing about this one is they gave us it already. So our formula, a to the n, is equal to 1 times 3 to the n minus 1. And there's those. Okay. So that was solving problems using geometric sequence to find the next term in the sequence. Okay. The next set of examples then, it says, given a term in a geometric sequence and a common ratio, find the 8th term. Okay, so in this case, we're given the 5th term in the first one. We're given the 5th term. We're given the ratio. We have to find the 8th term. And then it wants to write the explicit formula as well. Okay. So again, we're going to use our formula. A of n is equal to a of 1 times r to the n minus 1. We know the ratio and we know of terms. We have to find the 8th term. So we're going to find the a of 8. Now remember, that doesn't necessarily have to be the first term. It can be any term in the sequence. We know the number 243. We've got a ratio of -3. N minus 1, 8. But remember, 243 is our 5th term. Okay, so that's going to give us our... So 243 times -3 to the 3rd. -3 raised to the 3rd is -27 times 243. And you're getting some big numbers in here, but the 8th term is going to equal -6,561. Now it also wants us to write the explicit formula. So we have to write the explicit formula. So in order to write the explicit formula, we need to know the first term. Okay, so the first term is going to be a term that we know, times our ratio, which we know now is -3, n minus 1. Now, 1 is there, minus 243 was my 5th term. So that's 243 times -3 to the -4th. So we're going to take -3 raised to the -4th. Take that times 243. And then my first value, if we do that, you get a of 1 is equal to 3, which is always nice. So then our formula, a of n, is equal to our a of 1 value, which is 3, times our ratio, which is -3 to the n minus 1. And you're done. Okay, so a little bit different with that question. But yeah, so there it is. Question number 8, they made question number 8. This question, last example here, made this one kind of nice again. They want you to find they want you to find those things again, but now you're given a of 1 and the ratio. So we can write the explicit formula right away. A of n is going to be 3 times your ratio to the n minus 1. There's your formula. You're done. Now if we want to find the 8th term like they ask, that's going to be 3 times 5 to the 8 minus 1. And again, it's minus 1 because 3rd is our 8th term. So 5 raised to the 7th. And you get big numbers in this, a lot. $232, 3, 4, 3, 7, 5 should be what you got for a solution. Okay. So there's geometric sequences. I think I'm going to cut this into a couple days. I think we're still good to go, probably with the test on Tuesday. But we're going to cut this into 2 kind of separate lessons instead of making one like 8-hour video, I guess. But yeah, there's geometric sequences. If you look at the assignment itself, it's going to talk about geometric series. We'll talk about that in the next video. So really, for this part of the lesson, you're just looking at questions 1 through 8.